So this is something that's really powerful feature of Hammer, something that any Hammer user, I strongly encourage you to learn about and take advantage of. I see a lot of users that tend to model things separately, where they have a separate model file for every situation that they're trying to model, and it's a little harder. It's harder to maintain, and then there's a lot of downsides to that. With scenarios and alternatives, you can basically have one model file that has all those different situations that you want to analyze, all stored in that one model file. The other benefit of that, something that we're going to cover next, is that you can actually see results for those different scenarios in the same graph or in the same window. So it's a lot easier to kind of compare those results. For example, I was talking about how do we what kind of demands or tank levels do we use for the initial conditions? Well, you can compare that. We can set up a scenario to check to see what's more conservative. Starting the model with the tank levels high or tank levels low, or you can try lots of different things. And then when it comes to transient protection, you can try a number of different strategies. Tank, air valve, different sizes of them. You can have a separate scenario for each one of those, and then easily compare those results, to assess which one is best. So getting back to Hammer, so we'll continue on with our skeletonized version here. So I will point out that when we just ran that, we actually ran a scenario that I had already created called pump shutdown, average day demand, no protection. So this is just a child scenario of a scenario that was already in the WaterGems model called 2015 average day demand. So basically I wanted to see, how things were doing just, with average day demands, and that's an extended period simulation. So another thing we could do is see what happens when we try initializing or starting our transient event with a different type of demand. So for example, peak hour demand. So what I can do is just create a new child scenario, and I'll call this pump shutdown peak hour demand, no protection. So what we want to do here is choose the corresponding alternatives. So your alternatives are basically where your data is stored. So the different categories. So for example, a physical alternative stores any physical data. Transient alternative stores any transient specific data, like those things that we saw in the transient section of your various element properties. So the thing that we want to change in the peak hour demand scenario is actually the initial conditions, because peak hour demand is actually a steady state simulation. So we want to make sure that we are starting the the simulation at equivalent tank elevation that we tried in the other one. So remember when I graphed the tank and the pump, the tank was up near the top. It was actually at an elevation of 177.9. So what we want to do is make sure that this new scenario is using the same tank elevation to kind of compare apples to apples. So that's stored in the initial settings alternative. So what I'm going to do here is create a new child alternative of the one that we're using in the other scenario. We're going to call this peak hour demand transient. And then back in the scenarios manager, so when I click on this new scenario here, if I go over to the properties, I can select the different alternatives. So for initial settings, I'm going to choose the new peak hour demand transient alternative that we just created. Then I'm going to make that scenario current and then make that change. So I'm going to go ahead and set the initial elevation of our tank to be equal to the, again, that 177.9 that we started the last simulation at. The other thing we have to do is make sure that the pump in question is starting on. So the initial status of a pump is also something that's stored in the initial settings alternative. So we're going to change that here. And just to show you, if I switch back to this scenario, the pump is back to being off, and the tank has, the old initial settings. So they're tracked separately. So you can, keep these things separate and make changes over here without worrying about, impacting the other scenario. Okay, so what we're going to do, and also I'll point out that you could do something similar to this, where instead of looking at different demands, you could try a different tank level. So you could create another scenario with another initial settings alternative that has, for example, maybe the tank is down near the bottom or all the way to the top. So that's, I won't do that today, but that's another thing that you can potentially do. So let's go ahead and compute initial conditions for this. So it's just a steady state simulation. And because of that, we don't actually have to change the transient solver. Hammer will know, because it's a steady state, that it's going to basically look at hour 0. So we don't have to actually change the 7 hours here. We can leave that alone. So now let's go ahead and do a validate, and no problems found. So now let's compute transient. Okay, so now let's go ahead and open up the transient results viewer again, and we're going to compare side by side transient envelope. So I'm going to put this one over on the right side, and here's our profile. I'm going to switch back to the previous scenario and open the transient results viewer over here and profile that so we can kind of compare these two things. Okay, so looking at the envelope, one thing I notice is that the maximum hydraulic grade on the left side, which is the average day demand case, is about 220 meters over on the left side. Vapor pocket about 100, let's say 130 liters maximum. When we look at the peak hour demand, looks like things are a little bit better. So maybe about 215 for our maximum over here, a little bit less on the vapor volume. Looking at the blue line, the minimum, looks like over here on the left side, you can see this is a little bit, the pressures were a little bit lower up on this hill than they were over here. So one might conclude that maybe it doesn't matter too much, but in this case, we're going to go ahead and proceed off of the average day demand scenario to select that as our worst case scenario